Okay, we're in the section, it's Newton's method, and we're doing the homework now. The way I'm going to do this is I'm going to set the problems up at the whiteboard. What I mean by setting it up, maybe I'll do some computations, but if it really requires some difficulty in computation, I'm going to go to Sage. So for example, number one, I'll go to the whiteboard, I'll set it up, and I'll probably do the first computation, but I don't think I want to do X2 and X3. So I'm gonna leave on the whiteboard the place I'm stopping at before I go to Sage for each of these problems over here. So for number one, we'll go through how to set it up. I'll probably just compute X1, and then I'll say we'll come back to it later to compute X2 and X3. You need to take notes if you're watching homework and did not done this already, and make sure that when I go to the Sage, my whiteboard will disappear, and I'll just do the Sage. All right, but I'll check it against my key to make sure I didn't do any errors. And if I do any errors, I'll have to go back and correct at the whiteboard. All right. So, I'll do number two that way. Number two, I'll take their guess, which is X naught. We'll talk about how to get that guess. And then I'll do those computations, X1 and X2. I'll do number three for you at the whiteboard. What does that mean? I'm going to set it up for you, but I got to be honest with you, computations, they're going to be tough. They're going to require the use of a computer. The software that I'm using is going to be Sage. You don't have to use Sage to do the problems, though. You can use whatever computational device you want, including if you're using a slide rule. Not a good idea, by the way. Or a calculator or your cell phone. You need to learn how to compute. No one's going to do computation for you. You have to do it yourself. All right. So I'm also going to do number four. And there's four problems, and we'll do them all. We'll set them up. Now, of course, they start in difficulty of being, easy, a little more difficult. And for a lot of students, I know just from experience, have a tough time. All right. The big joke on number four is, you may be surprised by this. And I would often consider this to be a gift if I were a student in school, that sometimes these questions appear on exams almost verbatim, and students look at me and say, how do you do that? And really what they're communicating to me is that they don't do it. They have not done their homework. That's what they're communicating. Now, some people may think that's an attractive thing to admit to someone. In the real world, though, when you openly admit you're unprepared, you pretty much have told someone a great deal about yourself, which basically is going to be used against you long term. You don't want to do these things, all right? You want to prepare. How do you prepare? You've got to put the time and effort in. And that's where a lot of students, their weak link is putting the time and effort in. So we're going to talk about each question separately. I'm going to go to the whiteboard. Again, I'm going to set it up. Maybe I'll do some simple computations, but the bottom line, all heavy lifting, I'll go to Sage to do that. And I'll indicate that at the whiteboard we're going to do. All right. So I am going to go to the whiteboard now. Give me a second to do so. All right, we're problem number one, and problem number one is the easiest problem to do. I mean, it's really an easy problem, all right? I'm even going to say you could even do it by computation by hand, but I'm going to leave the heavy lifting to Sage. So what do I got? I'm going to write down what Newton's method looks like to me. It looks like I have, xn plus 1 would equal xn minus f of xn over f prime of xn. Well, I'm just going to set it up because it's really not asking me to even think about it. It just kind of set the problem up and compute some numbers. So what's f of x? I'll write it down for you. It's x squared minus 18. And what's f prime? I got to write that down. And what's that going to be? 2x. So I'm going to go over here. I'm going to write that down now. So I get xn. We'll talk about what xn is later. Minus. Well, what's f of xn? It's xn squared minus 18 over 2 times xn. All right, I like to simplify these guys, and someone says, why is that? I'm going to have to actually do the computation at some point. So common denominator, and that would be 2xn. What goes in the numerator? 2xn squared. Yeah, you need to know algebra. Xn squared plus 18. So what do I get over here? Well, I get xn squared plus 18 over twice xn. And what's this going to be? This is going to give you the next s, xn plus 1. So I'm going to say, I think I could take their first guess. And someone says, what's their first guess? Well, they said their first guess, x naught, x0. I'll write this over here, is equal to 4. So what's this going to give me? And again, I want to point out to you, if n is 0, it would give me x1. So let's write this down for you. So what's x1? I'm write down for you. Would equal, well, this looks pretty easy to do. I take the x naught and square it. That would be 16 plus 18. And twice 4 is 8, right? And what does this give us? Let's write this down. 16 and 18. And again, I could do the computation. I don't need a calculator to do this. 16, 18, 34 eighths. I'm going to divide by 2 and I get 17 quarters. So I know x1. And what's x1? 17 quarters. I see it. All right. This is x naught. Now someone says, could you do x2? I could. All right. And I'll tell you why I can do that. What's x2 going to be equal to? Well, it's going to be 17 quarters squared plus 18 over twice 17 quarters. I got to be honest with you, though. I don't really enjoy doing that, but I could do it, and you could do it too. And this is something where you get in exams where a calculator's not being used. Maybe they'd ask you to, compute x1. Maybe they'd ask you to compute x2. But I got to be honest with you, getting x3 and x4 and x5 and x6, that's going to be a backbreaker. So I'm going to claim over here is when I go back to Sage, what I'm going to be doing is I am going to be using this formula. So what you want to do is you want to have this circled, right, on your piece of paper. So when you go to Sage, you know what I'm doing. I'm going to do this in Sage, and you would need to know that x naught is equal to 4. I'm actually going to use this in Sage when I come back to it. So I'm going to stop this problem now, go back to Sage later, and then I'll check to make sure I'm getting all of these answers over here. I'll make sure of it, including those integer ratios, and we'll go through it. All right, let's go to problem number 2. And all I'm going to do is set it up. Right, when I set it up, then we'll talk about what I'm going to do, which is go to Sage. Let's write this down. All right, so what does it say? The figure is of the graph. It says use Newton's method to approximate the unique real root of f of x equals 0. So I'm going to tell you, they want me to approximate this root over here, right? What I want to do is certainly come up with an approximate. And as I do that, I just want to stick what they have in the key, and it's minus 1.17. Let me go through that. So what they did, they blew this up, and they said that this is approximately minus 0.117. Now, someone says, could I use a different number? Of course you could. Why do I use this number? I want to make sure that I can match the computation that will be brought to me. You'll notice sometimes in WebAssign, they give you the initial guess, so that way they could grade you on the second guess and the third guess and so forth. That's what we're trying to learn. Let's go over here, and I'm going to write down Newton's method for you. And what's it going to be? Well, I got f of x. What do I need to write down? I need to write down, whoops, sorry about that. I need to write down f prime. Fairly easy to do. What do you get? 3x squared plus 2. All right, I'm going to write a general form down in Newton's method. And let me put this down for you. So what do I get over here? I get x minus f of x. What's f of x? X cubed plus 2x plus 4 over its derivative, 3x squared plus 2. Now, I like to simplify these guys, but I'll be honest with you, you don't have to simplify that because you're going to plug this into a computer, right? You're going to plug this in a computer. So if you say, I don't want to simplify, don't simplify it, all right? But what I'm going to put in the computer, I'll tell you what I'm going to put down. This thing over here is going to be obtained by this, xn minus xn cubed plus twice xn plus 4 over 3 xn squared plus 2. Now, again, I'm going to go to Sage later. This is going to be typed in with the understanding that my x naught is going to be assigned the value minus 1.17. And again, I'm going to do this on Sage later. This can be done with Sage. So I set it up. I'll come back to Sage. When I do that, I'm going to claim I should be getting these numbers over here. And we'll go through that one step at a time. If I'm not getting those numbers, I'll say I made a mistake. Let's go to number 3. Again, I'm just setting it up. And my understanding of this thing over here is I need a function. So I'm going to go through the steps for you. And what they want to find a solution to this over here. And they do give me a graph, by the way. And looking at the graph, I hope you realize that, one of these functions is a sine function. I'll put this one over here for you. So this graph over here is 5 sine x. And this graph down here, the blue one, I'll put this over here, is going to be, this graph over here is going to be 3 cosine of 2x. Now, you realize when you took math 120, you solved equations that look like this. I'm not going to say they were difficult to solve, but the bottom line is they're not asking me to go back to math 120. They're asking me to use calculus to solve this problem. And they want this point of intersection over here. Now, I want to claim over here to do Newton's method, I need a function. So what I want to do is I want to go through that with you, how to do that. And a way to do that, I'll just simply put this down over here. So 5 sine x equals 3 cosine 2x. So what I'm going to do now, I'm going to solve for 0. This is the first thing I'm going to do. Now, why is that? Newton's method is trying to find the roots of something, and that's going to be the 0. So let's write this down. So I'm going to write down, 0 equals 3 cosine 2x minus 5 sine of x. You know what? I'm going to write that a little different. I'm going to erase that. Really, I don't like that. I'm going to write a different one down. I'm going to write down 5 sine x minus 3 cosine 2x equals 0. And I'm going to say this is my function. And what am I looking for? I'm looking for a root of it. By the way, there's an infinite number of roots. We just want to find the one that's indicated in the picture. And they gave me a nice picture, right? They gave me a nice picture. I want to point out they're only looking for the solutions that are in that interval there. And they give me a picture of it. And I'm looking at it, and I think I could probably get the x naught. So looking at it, let me point out what I'm doing. I'm going to use their number. I just want to look at this. And what I'm seeing the root of this, where the x occurs is around here. And that's between 0 and 1. Now, sometimes I wonder what that number is. If you look at this, 0.2, 0.4, 0.6, 0.8, and that would be 1. So I'm going to say it's like 0.4 something. Now, I'm going to use their guess, though. All right, I'm going to use their guess. Now, why is that? I want to make sure that when I use this number, I get this one next. How do I do it? All right, so I'm going to write down, I got to get to that Sage code. So I got to write down this F prime business, right? I got to write F prime down. Whoops, go back to black ink. And what's that going to be? Well, that's going to be 5 cosine x, let's see, plus 6 sine 2x. Wow, now what I got to do? I got to do that xn business, right? Xn minus, well, I'm going to write this a little simpler. I'm going to write it as f of xn. You'll see me do this in Sage code as well. And f prime of xn. What's that going to give me? It's going to give me the next guess up. And you'll see me do this in Sage as well, with the understanding that this is f in Sage. By the way, I got to back up over that. This is f. All right, that's what f is. And we're going to use what guess? Let me write this down for you. X naught. What guess we're going to use? I believe it's at 0.42, right? Yep, 0.42. All right, let me repeat this. We're going to come back and we're going to do this in Sage. We set it up. we're going to do this in Sage. This is why you need to be taking notes, have this stuff written down. It's so important you can take notes. Let's go to number 4, a little more difficult, and I'm going to go through that one with you. Now, number 4 says, find the x coordinate and y coordinate of the point P. They gave me the figure where the tangent line to the graph of y, wow, this is like a tough problem. So let's write this down. This is the graph of y equals 6 cosine x. That's not so bad. Now someone says, what's P? P is really easy to write down. It's going to be a point. And what's the point going to be there? Well, let's write this down. It's going to be x, comma, y. Well, what's y? 6 cosine of x. All right, I got that down. Now, what did they say? Again, if you have to read it more than once, read it more than once. Read it 20 times if you have to. I got to find this point, the x coordinate and y coordinate, point P. So I'm trying to find this. Now I could look at it and say, oh yeah, it's roughly this number, but I got to get it better than just saying roughly this. Like I know it's roughly 2 point something for the x. And looking at the y, I'm going to say minus 5 point something. All right, it's just rough. I'm not saying it's the right answer. But what did they say? They said the slope, right? That line is tangent, so it's got a slope, right? What would the slope be? Let's write this down. So the slope of this line over here, m, is the important part. We get the slope, right? Well, it goes through the origin. So what's going to be? Change in y. So let's write this down. 6 cosine x minus 0. This is the origin. This is the point 0, 0. I'm just writing slope down. So that's going to be change in y, 6 cosine x minus 0, and then x minus 0. Let me keep writing that down. That's a slope. So it's going to be 6 cosine x over x. That's a slope. But they said it's tangent. Now, what does that mean? That means it's equal to the derivative evaluated at f. So the slope of this thing over here is the same thing as dy dx evaluated at that x value. What's that going to be? Well, the derivative is just going to be minus 6 sine of x. All right. Now, this is critical, absolutely critical that you come up with this equation over here. This is the equation we have to solve. So let's go through it. And it looks like it might be tough to do, but let's write this down. So you can get 6 cosine x equals minus 6x sine x. Okay. What are we going to do now? Well, I got to solve this thing for 0. All right. And how would I do that? I guess what I would do is I would add 6x sine x to both sides. Write this down. So 6x sine x plus 6 cosine x is equal to 0. I'm going to say this is my function, f of x. All right. I'm going to circle that, indicating this is the most important step in starting the journey of getting a solution to the problem. What am I going to do now? I'm going to use Sage. How am I going to do that? I got to write Newton's method down. And what's Newton's method going to be? Well, it's going to be x minus f of x over f prime of x. All right. And we're going to do this. What the understanding is, this thing's here is going to use to generate new and new and new and new. Each time it's going to give you a new guess until it doesn't change. But I got to get the x naught, and I want to use what they're doing, right? So looking at it, they're saying that they're using, let's see what they use for initial guess, 2.8. Let me tell you why they did that. All right. But again, I want to use what they got over here. If you look at this over here, they said the x appears to be about 2.8. Okay. I'll write this over here. Give me 1 second. And again, you might have a tough time with this problem just by conceptually thinking through that. So they're saying about 2.8. I'm sorry about that. So x naught, I got back to black ink. Okay, so we talked through it. And what I'm going to do now is I'm just going to go and stop my, like almost I'm taking my notebook, putting it on the side and saying, I got to go to the computer now. I have to go to the computer now. And when I go to the computer, someone says, where's your notebook? Well, you need a notebook, right? My notebook's in front of me, but it's going to disappear from you. And you have to have a notebook in front of you. And this is what I'm saying. Take notes, take notes. All right. Let me do a new share. And the share I'm going to do with you is my desktop. And we're problem number 1. I'm going to pull up Sage. And give me a moment to do so. And I'm going to show you what this looks like to me in Sage. All right. This is number 1. So someone says, can you remember what I can't? I have no idea. I'm not going to do that problem again. I took notes. Right. So someone said, what notes did you take? Going back to my notebook and I remember doing this. And I said that I was going to say, well, let me reset first. Right. And I'm going to set X to be a variable. Oops, got to put that quote in, huh? And then I'm going to put my, the function down that I wrote down. And if you recall, I circled it in red. It was X squared plus 18 divided by 2 times X. You know what? I forgot to put f of X down there. Now someone says, you know what? You shouldn't use F because the problem was F. It doesn't matter what I put down. I'm just saying this is my new function I'm writing down. It's my Newton method function. I'm going to call it, I'll call it N. N of X is equal to that. Okay. Now what I'm going to do, this is my Newton function now. And my Newton function is going to generate guesses when I give it a guess. So I'm going to say X sub 0 is going to be assigned the number 4. Now I want to find out, what does N of 4 give me, or N of X not give me? Well, it gives me 17 quarters. I see that right here. All right. Now I'm going to give that to X1. Let me write this down now. X1 is equal to N X naught. And I want to display X1 now. Okay, you can get better at time. You try this, you're going to get better. So what does this do? This now takes it takes N, Newton's function, at X naught, evaluates it and assigns it to X1. And what do you get? 17 quarters. Now what I want to do is I want to do X2. What's X2 going to be equal to? N of X1. And what do I want to do? I want to display that. Okay, I want to display it. What does it give me? 577 over 136, just like it says in my notes. Now let me do X3. What's X3 going to be? Equal N of X2. And what do I want to do? I want to display X3. And I got it. I got the same number they got. Now someone's going to say, could you do this with decimals? Of course I can. If you want to take these numbers, for example, the computation we just did, let me point out what I mean by that. If I want to approximate this, I'll do the dot notation. Whoops. And I get an approximate there. If I wanted to do the X2, I think you get the idea, right? Dot N approximate. And what do I get? The number they got there. And you could do this all day long. If I wanted to go back to the 17 quarters, it's going to be X1, right? Dot N, and that'll approximate it for me. All right. Not bad. All right. Let's go to problem number 2. And again, all I'm doing is looking at my whiteboard notes. You should have those notes. I'm going to clear this out. Okay. I'm going to look at my problem number 2, and I'm just looking at it. That's all I'm doing. I'm looking at it. I'm going to do reset again. I'm trying to remember. I'm going to set X to be a variable. And what's the variable? It's X. And then I'm going to write this down. And what I'm going to write down is, I'm going to write down what F is now. I think I can do it. And what's F? F of X is X cubed plus 2 star X plus 4. I need to write its derivative down. So I'm going to say df X is going to be assigned the differential, the derivative of F of X with respect to X. Return. Okay. Now what do I have to do? Well, I think I'm ready to write down Newton's formula. What's that going to be? Newton's formula X is going to be a function X minus F of X divided by df of X. Hit return. Now I got to do the guess. What guess did I say? I said X, the first guess was minus 1.17. I'll hit return. That's done. I want to get the next guess. What's that going to be? N of X naught, but that's going to be assigned to X1 now, right? Equals N of X naught. I want to display that, which is going to be X sub 1. You don't need to use the dot notation because there's a decimal in the number now. Let's see what we come up with. Wow. Is it the same number they got? I got to go to the next page. I'm going to look at it. What number did they say? Minus 1.1795. Wow, they got the same number. Let's put down X2 now. X sub 2 is going to be N, that Newton function we just defined, X sub 1. And we're going to display X2 now. And what I get? Let's see if we get the same number they got. Minus 1.17. Yeah, it's the same number. Amazing. By the way, I could do this all day long. Let's put down X3. What's X3 going to be equal to? N of X sub 2. We are now going to display X sub 3. Well, there was a little bit of a change. Let's do X4. I think you're getting an idea, right? Equals N of X sub 3. And I want to display X sub 4. Now remember, if I type something in wrong, it's not going to blow up. And what did you get over there? Well, what I notice now, there's really no change in the problem. All right. So by the time I get to the fourth, iteration of this thing, I got no change. I did pretty good there. So I'm going to clear this now. All right. Now someone says, oh, if you clear it, I don't have any record of it. It's a video. You can rewind the tape. Let me clear it. All right, let's start. Reset. I think we've been doing this for some time now, right? Getting much better at it. Much more comfortable with programming, by the way. Get this over here. And I got a problem. I'm got problem number 3 now. And I'm going to look at my notes and I see it and I'll write it down for you. And what's f of x? Let me write this down for you. F of x is equal to 5 star sine of x. I'm just copying from my notes, by the way. The same notes I put in the whiteboard a moment ago. Minus 3 star cosine of 2 times x. Remember, if I type something in wrong, it'll let me know that. I'm going to put down df. I need the derivative of f. Now, I know in my notes I wrote down the derivative, but Sage can do it for me. And if it's doing my computation, I might as well do my derivatives. That's going to be diff of f of x with respect to x. I did that. And by the way, I have an answer key. If I make a mistake, I'm going to know I made an answer. Oh, by the way, I forgot to scroll my notes up. And again, getting these numbers over here. I was looking at my whiteboard. Sorry about that. So we're doing this one over. We're doing number 3 now. All right. And again, what we did at the whiteboard is what we did at the whiteboard. I'm really looking at my whiteboard, not the thing behind me. And I said that we could write a new function down. I'm going to call it nx is equal to x minus f of x divided by df of x. Remember, we just did that, right? And then I got a couple of initial guess. And I think the initial guess we said was x0 was going to be assigned the number 0.42. Oops, sorry about that. And how do I get x1? x1 is going to be equal to n of x naught. Oops. I want to display x1. Let's see what happens. And what do you get? Well, then I'm gonna scroll over here, and what do they got? Well, yeah, they did pretty good. All right, now someone says, I wonder if it's going to change. Did they give me more numbers? No. Let me keep going. Let me do another one. All right, so I'm going to do x2 is equal to n of x sub 1. And I want to display x sub 2. Now, I hope you agree there's a change in the number, but they're very close, by the way. Let me go to x3, see what happens. That's going to be n of x2. And I want to display x3. Whoops, sorry about that. It's still, there is a slight change there, right? I'm going to keep going. Let's go to x4. That's going to be n of x3. And I want to display x4. I'm looking at it and there's no change now, right? You see how fast that went? I mean, really, computationally, this is really something for a computer to do. For us to do it, though, it would be a nightmare. All right. This is why we're trying to learn to use a computer. All right. So I think I did okay there. Let me go to the next question. And I'll make sure I'm doing the right thing. We're problem number 4. So I'm going to clear. I'm getting much better at this. Reset. I'm pretty sure I did x the variable last time, right? By the way, you don't have to do that because x is automatically a variable in Sage. I'm going to write down what f of x is. And if you recall, this was my work. I had to come up with f of x. And what did we say f of x was? We said it was equal to, and we're making an assignment, 6 star x star sine. I'm just looking at my whiteboard, by the way. X plus 6 star cosine of x. Wow, that was pretty easy. Let's see if I type that in, 6x sine x, and then 6 times cosine x. Well, no error there. Then I'm going to do df, which can be the derivative of x. Again, I'm using Sage as a calculator. I might as well use it as a differentiator too. And I'm going to differentiate f of x with respect to x. By the way, I'm not sure what it looks like. I'm just typing it in. And I got this over here. Now what I'm going to define a function. This is Newton's method. A new function nx is going to be x minus f of x divided by the derivative of f. And hit the return. And then I think I said I was going to make x naught, what number? 2.8. All right. Okay. And that was, that was our little circle in red thing. All right. That we did that. We did a lot of, no, I can't say a lot, we did some work. All right. So I'm going to, basically go through the steps now. All right. The steps. So I know what the question is, but before I do that, I'm going to say that I want to start getting the x to some level of precision. All right. So what am I going to do? I'm going to say x1 is equal to, ready for this? N of x sub naught. And I want to display x sub 1. I got this. Clearly there's been a change. 2.8 to 2.7983 is definitely a change. Let's get x2. Let's see how good we can do. Is equal to n, that new function I have defined, that's Newton's method, x sub 1, and I want to display x sub 2. Let's see if there's been a change. There's definitely been a change. Let's keep going. Let's do x sub 3 now. What's that going to be? N of x sub 2, and I want to display x sub 3. There's definitely been a change. Not a great change, but there's definitely been a change. Let's go to X sub 4. Someone says, how long should you do this? Until you don't see a change. All right, on your computer screen anyway. N of X sub 3. And I want to display X sub 4. And I don't see any change now. So someone says, okay, you got the X. How do you get the Y? F of X sub 4. Right? That's going to give us the Y value. All right. So let's see if we can do that. And I'm going to see if I can do that and see what I get. Let me make sure I'm saying this right, though. They really, the Y value. Oh, I'm sorry. That's not true. I made a mistake. I have to go back and look at my notes. The reason for that, let me point out what I'm saying over here. I made a mistake. It's not the F. I forgot what we were doing over here. It's the Y value. The X value is 2.7. And I'm glad I looked back at the picture. 2.7, yada, yada, yada. That's the X value. What's the Y value going to be? Well, the Y value is going to be the function, not F of X, but it's going to be the 6 cosine of X. And I apologize for saying that. So let me type that in for you. 6, and we'll look at the picture, by the way. Cosine of X sub 4. I'm glad we have a key to look at too. What's the number? -5. Does that make sense? Looking at the picture, it does make sense. I'm seeing that right over here. So -5. All right. Let's go over here, look at it. Did I get the approximate correct answer? Yes, I got the 2.798. Did I get the approximate Y answer? Yes, that's -5.650. All right. So what's the problem with Newton's method? Basically setting it up. All right. Once you set it up, though, I'm hoping you have some appreciation for why a machine should be used. It's used because it is so easy to use it. That's why. Let me clear this out and point out that you should be able maybe to rethink what we just did, try and try again until you get what we've given you. You can watch these videos as much as you want. I also want to point out, I'm also going to post another video about doing Newton's method. All right. Relatively simple on a computer. We're just getting our feet wet in programming. For those students that know about for loops, you might be able to do this by a for loop as well, where it's going to put all the answers down. And you would judge when to stop that for loop by when there's no change occurring. All right. But we did each of the problem in the homework by writing down some initial work at the whiteboard and then going to Sage to do the remaining work in Sage. Thank you for your attention.